Oh, I'm morning.
Yeah, I'm sorry. I'm just saying,
That's a purple for a lawyer.
Look, here's a girl. Yes.
All right, everybody. Well, good afternoon and welcome. Hope that you guys are having a good day. It's been warm and sunny out there, but I've been inside giving exams. So I have a whole stack of them now. If anybody that isn't doing anything tonight, happy to get some help with that. No, just kidding. But actually, on a serious note, I probably will not stick around in my office real late tonight. If you have questions for me today, I'd recommend you come right down after class if you can. Otherwise, plan on doing it but via email, perhaps. I'm going to probably head off to a coffee shop somewhere for the evening and just crank out my grading as soon as I can, rather than just sitting at my desk, which I don't like to do I don't like to do big grading sessions down there. I have to have a coffee machine and something to eat nearby to keep my mood up, which is good for the sake of the grading. So anyway, I will go downstairs for a little while after class, but not for a huge amount of time. There is a homework assignment due tonight. I've been getting a few questions on it. If you do have any questions on that, do try to catch me earlier rather than later after class. That would be awesome. Yeah, so I pulled up the Canvas course page because I just wanted to point something out to you guys. We have an exam coming up, our first midterm, not this coming Tuesday, but the Tuesday after that. And so I went ahead and got a little bit organized for that this week so that you guys can have some stuff to look at. There is another homework assignment for you to work on that's due next week. He's trying to get my attention. There is another homework assignment that's due next Thursday, and you guys should be good to go to start on that after today's class for sure. But I wanted to point out there is a folder in Canvas called Midterm 1 Resources. And those of you who've had me before already know this, but if you haven't been in my classes before, you might not realize I have a lot of resources to help you with your preparation for the midterm. In particular, I have two different sample midterms up here for you to practice on. One of them was the one I gave last year, and then another one from years ago when I taught this class. So one of them's in uppercase letters and one of them's in lowercase letters. You'll see I have the exam itself and then also a solution guide for the exam. So I'd recommend that you don't just go in and read the answers right away. It'd be better to probably try these problems on your own. You might even try to take one of those two sample tests almost as if it was for real, like set yourself down for 75 minutes and just see what you can do. I wouldn't do the sample midterms until you've actually studied a little bit for this exam. Otherwise, it might be a little frustrating for you if you don't have things in your mind that you need to for the exam. But anyway, once you've done a little bit of studying, you could try one or both of those. By the way, this is all just take it or leave it, right? This is optional. Nothing is assigned here. If you feel ready to go and you don't need to do this stuff, that's totally okay. But I just would rather have it there for you so that it's available in case you might find it helpful. There's also, okay, so then there's also a document that's called, it's down here, it says Midterm 1 Review. So maybe this would be good to look at before you try one of those sample exams. It talks about what sections are going to be covered by the exam. You can see it's going to be basically chapters 2 through 6, except not chapter 4. And only the sections that we talked about, right? So I've just got that there. Extra office hours, I'm kind of still working that out, but I'm going to probably do some Friday and Monday stuff, which normally I don't always have Friday and Monday hours beforehand. I also was planning on doing a review session, and with a class this big, I actually think it might be better if I do it twice so that people who can't come. So you might notice we don't always have a life around here. I figured Friday night a time slot. It's only because I know many of you cannot come like earlier in the day if you're teaching somewhere. So I thought, well, I might as well make sure that I'm doing them late enough in the day that people who are working already can actually attend to these. So I'm going to do one of them on Friday evening, not this Friday, but next week on Friday at 7 o'clock. I'll be here, but I'll also be in Zoom. So if you don't want to come to campus and you just want to jump into Zoom, I'll have my computer going like usual. And then I'm going to do another one on Monday at 5 o'clock. Now my idea for this is I have some problems already prepared to do, and I'm going to start on the Friday session and go through them. If I don't get done with all of them in 2 hours, I'll probably just cut it off. And then on the second review, I'll probably start with those, and then I'll start with anything I didn't do in the first review, but then I'll cycle back through some of the same problems again. Does that make sense, Alyssa? Yes, that's what I'm talking about. So I'll record them. So if you can't make it in Zoom or you can't make it in person, I'll also put links out for you to watch it at your leisure. I see already I have the date wrong here. It's not,
Just about to say.
Yeah.
this should be October 7th.
And Friday's the fourth.
Okay, I'm sorry, I'll fix that. Should be the 4th and the 7th. It's the Friday and the Monday before the exam. I probably would do a Saturday or Sunday as well, except I think I need to be away from Fullerton that weekend. Yes, Jose?
Usually like how long do you spend?
Well, for the review sessions, I'm probably gonna stick pretty close to 2 hours. If you want to come late, if you want to leave early, all of that is just fine. It won't offend me if you can't stay for the whole time. Just come for whatever you can, either in Zoom or in person. And if you can't come at all, or you just don't want to come at all, that's fine. You can also watch the recording afterwards. Or you can say, you know what, I feel ready to go. I don't even need to think about the review session. That's also another option. But I figured I would do that. In my upper division classes, I like to do these review sessions, but it's entirely optional, as is pretty much everything in this resources folder. I've got some of the buzzwords that we've covered listed here. We've gone all the way pretty much through chapter 5 so far, and we've got another week or so to hit chapter 6, which is the plan. And then I've got a list of the theorems that we've covered, starting with the pigeonhole principle and kind of going all the way down. So you can use it kind of like a checklist. Maybe some of you like to use flashcards. You could put these theorems onto the flashcards that you're making and just kind of, on one side you might write binomial theorem, and on the back side, state the theorem, right? Or formula for the number of R permutations of a multiset. And on the back side, write down the formula. So stuff like that might be useful. And then I've got another bullet list of just here's all the things I think you should be able to do. So you can, again, think of this like a checklist. There's not that many things here, about 6 or 7 or 8 bullet points of just some of the types of questions that you should be expecting. Again, instead of just asking me, oh, what's going to be on the exam, my advice would be just look at the sample tests that are already up there. I won't write this exam, trust me. I will not have it written until Monday night, late. I don't write my exams early because I like to be able to just be totally free and clear of answering anything that might come up. So I won't be able to tell you about it, but you'll be able to use this thing as a good guidepost for the types of things that I'm probably going to ask you to do. And then some advice about the exam. I'll let you read some of this on your own time. But then I actually also have some extra practice problems down here. Now, so maybe before you try a sample test, if that's your plan, you might try some of these problems first. Just run through. These are just similar problems to what will be on the exams. I have quite a few of them here. That's quite a few of them, 14 of them. But then I'll just close this really quick and point out, I also have a solution document here. This is just all of my solutions to all of those 14 problems. Okay, so I wouldn't just read my solutions. If you're going to work on this, I would recommend setting the solutions aside and then looking at those later. But they're fully worked out solutions. And I also have the problems I'm actually going to do at the review session. So let's say you don't want to come to the review session, but you'd still like to see what the problems were. Well, here you go. Okay, I've got them all typed up here. And then I've also got the solutions to them typed up. So every conceivable way of learning. Whether you like to read the solutions, that's fine. Whether you want to come to the review session and listen to me talk about them, that's also fine. It's kind of you know, whatever works for you, okay? And as much or as little of this as you want. I think some people get a little overwhelmed. Maybe this is more in my lower division courses, but they get overwhelmed when they see a folder like this. It's like, oh my God, there's so much stuff here. I'll never be able to do it all. And it's okay if you can't do it all or don't want to do it all, right? So I just want it to be there, available. I'd rather make sure I'm doing my job as well as I know how to do it, which is to try to at least give you some things to look at if you want to. But it is totally take it or leave it. So that is my quick little overview about the exam. Again, it's not this coming Tuesday, but it's the Tuesday after that. And it'll be next week that I'm starting to think about those extra office hours, the review session and all of that. That's not immediately coming up, but in about a week or so, that's when that's going to hit us. Are there any questions about any of that? Okay, great. And of course you've got, I should probably throw the quiz that we just did the other day. I'll throw that into this resources folder too, in case you want to try it again at some point or refresh your memory about how all of that works. That quiz was certainly also filled with some problems that would be of the nature that I'll be putting together for your exam. Okay. So if at least for now there's no questions, of course we can come back and ask questions on that later. What I have done over here is put up a quick recap of this multinomial theorem that we were kind of finishing with on Tuesday, which is a generalization of the binomial theorem. Here we're trying to do an expansion of, let's say, the nth power of not just two terms added together, but let's say we have t variables here, so x1 through xt, and we want to add all of that up and raise it to a large power, n, right? So then it can be expanded out into a whole bunch of terms that just look like various words in these x1 through xt variables. Words with the x's being raised to various powers, and those powers are simply, I'm calling them n1 through nt, and the important thing here is that n1 through nt has to add up to n, right? That was the multinomial theorem. So it's just all possible, the summation extends over all possible n1 through nt, where they sum up to n. I should probably add here, let me just add that the n sub i's are all at least 0. And that would be for each I. That would be for each I. So we're not using any negative, we're not going to use any negative exponents, of course, when we do this calculation. And we see the multinomial coefficients showing up right here because there are many different ways to get the same word in our expansion. And so we can lump those together with this coefficient in front of it. Right, so that is the multinomial theorem. And I wanted to do a couple of just practice problems on that. A couple warm-up problems, because I think I was a little light on homework for this theorem. And it'd be good to have a little practice on it. So let's try these two warm-up problems to start off with today. The first thing I want to do is just write out the expansion of the fourth power of x1 plus x2 plus x3. Okay, so let's talk about that. So let's do the solution here to number 1. There's nothing about this that requires anything too creative or clever, but we do have to just be careful with the bookkeeping. In this first warm-up, what is the value of n? 4, right? So that's the exponent up here. And I have 3 unknowns, x1, x2, and x3. And so we're going to be writing down terms here that involve exponents that add up to 4. And the coefficients, we'll calculate them as the multinomial coefficients for choose each of these numbers underneath, okay? So we actually need to think about all of the ways that we can have, I guess in this case, 3, t is 3, right? How we could have 3 unknowns adding up to 4, given that they can't be negative. So we're talking about 3 numbers that add up to 4, they can't be negative. So for example, we could have 4, 0, and 0. So we were doing this, I think he asked me on Tuesday to do an example of it, and then I immediately had one that was too big. So today I'm actually gonna do one that's a decent size. Because there aren't as many of these as you might think. So we could have 3, 1, and 0, we could have 2, 2, and 0, 2, 1, and 1, and we keep going like this. Let's actually write them all down. What else could we have? We could have, so that was kind of started, that was the ones that have the first variable as the largest exponent. But then we could do, 2, 0, and 2, 1, 2, and 1, 1, 1, and 2. So we can move this 2 around to these different positions. We could do 1, 3, and 0. We could do 3, 0, 1, 1, 0, 3. That's also fine. We could do 0, 3, 1, 0, 1, 3. Those also would work. And we could do 0, 4, 0, and 0, 0, 4. Oh, let's figure out, by the way, how many of these we should have. This is a stars and bars problem with n stars. And the number of bars would be t minus 1. So there's 4 stars here, and there's 2 bars. So stars plus bars, choose bars would be 6, choose 2, which is 15. So far I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I missed one. Oh, I bet we can figure out what it is. 0, 2, 2. Yeah, I think so. Yeah, so there you go. So those are the 15 terms that we need to have. And so to write down our answer, oh boy. So the answer is going to be 15 terms, right? So let's just do each of them one by one. 4 choose, so it's always 4 on top, and let's do 4 choose 0 first. This term would coincide with x1 to the 4th, and then x2 to the 0, x3 to the 0, which I won't write down. And then the next term would be 4 choose 3 comma 1 comma 0. That would be x1 cubed times x2. I am going to write down all 15 terms here just to make this guy happy. Okay, and the next one is going to be 4 choose 2 comma 2 comma 0. This is going to be x1 squared, x2 squared. The next one is 4 choose 2 comma 1 comma 1. That'll be with x1 squared, x2, x3. And now I need another line to have more room. The next one would be 4 choose 2 comma 0 comma 2 times x1 squared times x3 squared. And the next one would be 4 choose 1 comma 2 comma 1 times x1, x2 squared, and x3. Okay, and then the next term would be 4 choose 1 comma 1 comma 2. You're not even writing it down. It's okay, you can take a picture of it if you want. X1, x2, x3 squared. And then the next term would be 1, 3, and 0. So 4 choose 1 comma 3 comma 0 times x1, x2 cubed. And then the next one would be 4 choose 3 comma 0 comma 1 times x1 cubed times x3. And then we would have 4 choose 1 comma 0 comma 3 times x1, x3 cubed. Getting there. Everybody's hand getting tired yet? This is not hard. It's just, a little bit of bookkeeping. The next term is 4 choose 0 comma 3 comma 1 times x2 cubed times x3. And then the next term would be 4 choose 0 comma 1 comma 3 times x2 times x3 cubed. And finally, the last 3 terms that are left, we have 4 choose 0 comma 4 comma 0 times x2 to the 4th. And then 4 choose 0 comma 0 comma 4, which is multiplied by x3 to the 4th. And then the last one, which I had missed earlier, was 4 choose 0 comma 2 comma 2 times x2 squared times x3 squared. And we better have 15 terms there. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 terms. Yeah, so that would be a perfectly good answer. Of course, each of these coefficients can be calculated by doing our factorial decomposition of everything. I think I'll just leave it like this for now. This would be okay. That makes sense? So that now I've really done a full-blown example of that. Questions at all? Okay. I probably could have done a better job of organizing these. I probably should have written them in descending order, like if you view them as 3-digit numbers, right? I should probably have started with 400 and then gone to 310, and then I probably should have done 301 next, you know, just so they're in descending order, but I don't know, being lazy today. Okay, if we're good with that one, let's try the second one. I promise the second one is much faster. For this second warm-up problem here. So the reason that the second one is faster is that I'm only looking for one term of the whole expansion of this expression that we have on number 2. So let's imagine that we're interested in the 9th power of x1 minus x2 plus 2x3 minus 5x4. We want the 9th power. And so you'll notice here that I have a particular term that I'm interested in, which is x1 cubed, x2 cubed, x3, and x4 squared. The exponents add up to 9, 3 plus 3 plus 1 plus 2. So this makes sense. And so basically for number 2, we see that n1 is 3, and n2 is 3, and n3 is 1, and n4 is 2. And so the coefficient of that term is just going to be the big N, which on this problem is what? 9, right? And I'm going to be choosing, so the answer, we can go straight to the answer. We're going to be taking the big N, which is 9 on top, and we're going to be then choosing 3, 3, 1, 2, this number. Okay? Which of course we can write it in terms of factorials. So does that look like the right answer? Camera over here.
No.
You still have coefficients on it.
Oh, I pulled a little trick on you here, which is that this isn't just x1 plus x2 plus x3 plus x4. If it was, that would have been right. But in this case, every time we grab an x2, we also grab a minus sign, right? And every time we grab an x3, we also are grabbing its factor of 2. So we have to look at how many of each of those we're grabbing. For x2, which is grabbed 3 times, right? There's 3 x2s, so we have a -1 that's being grabbed 3 additional times, right? And then the x3 has a 2 in front of it. I only grabbed 1 of those. So if I grabbed 1 of those x3s, I also grabbed an extra 2. And then we also have grabbed 2 of the x4s. And every time we grab an x4, we're also grabbing a -5 with it at the same time. So we also have to pull that into the expression. So it actually becomes, if I did this right, it should be -50 times 9, choose 3, 3, 1, 2. And so again, that would be, let me just write down one more step here and then we'll leave it kind of unsimplified. So -50, and then we would have on top 9 factorial divided by 3 factorial, 3 factorial, 1 factorial, 2 factorial. And that would be it. Okay. By the way, I forgot to mention, when we go to the midterm, I'm gonna ask you to do this with no calculator, because I'm basically gonna accept answers like that. I'm not gonna have you multiplying these things out. We're just gonna leave. In fact, I prefer the answer in this format because I can see sort of where all the pieces came from easier if you don't just simplify it into some enormous number. Nikolai? Yeah, so I'm basically, I know that I need to grab 3 of the x1s, right? And I need to grab 3 of the x2s. I have to grab 1 x3 and I have to grab 2 x4s. But when I grab those, right, I'm circling the entire term I have 4 terms here in this, in this set of parentheses. So I'll be grabbing, imagine that this 5 is glued to the x4. So every time you chose the x4 term, you also picked up a factor of 5. And I'm choosing it twice, so that's why that, actually it's a factor of -5. So I've picked it up twice. Clear enough?
Yeah.
Is everybody else okay with that? It's just a little twist that can come. The other game we can play, of course, is, you know, we could, I don't know, do something like this. Like, every time you grab an x4, you actually have to grab 3 of them. Now, if we did that, then of course this isn't gonna work because you're asking what's the coefficient of x4 squared. All of a sudden, the answer would be 0. Because you can't grab just 2 x to the 4ths if I'm grabbing them 3 at a time here. All right, so you can get into little tricks like that as well that can come up. But in this problem, I didn't do that. Okay. All right, fantastic. Well, that's the multinomial theorem. It allows us to expand expressions like what we have on the left here, with some variations, putting coefficients or powers inside those indeterminates that show up. Okay, well, guys, on Tuesday, we were supposed to do some group work, and then of course I ran out of time for that. So I'm going to give you just a short little bit of time for today to work on these. I'm gonna send you around this handout and have you guys find some whiteboard space that you can practice these on. Pass these back. I think this should be helpful. It's very similar to some of the homework problems that you're doing even for tonight. So hopefully it's timely in that regard. And I think I'll work on erasing the board, and once you have a handout, feel free to grab some board space.
Quick question that's bugging me. When we grab the negative, I know we're doing it 5, right? But like a little confused on the fact that.
We're actually doing it 3 times. We're doing it 3 times on this exam.
Oh, okay.
X2 is being.
And then we connected my part, and I'm like, yeah.
So you're grabbing that one twice, because if I want to find a term that has 2 x4s in it, then, you know, imagine this is sitting written out 9 times side to side. Those 9 factors, you grab the x4, but you just grab the x4, you have to grab the -5 as well. So that -5 comes in.
So even twice is not quite possible now, right?
Yeah. Yeah, that's right. You get 5 to the inside.
Hi.
Come on down, guys.
Nope, where's Lou?
Room for you?
Everyone. No, we hadn't yet.
Come on down, I'll get out of the way.
Oh.
You guys are gonna do this all correctly, right? I'm recording, this being recorded for the whole world to see on my. Sure you get it right. No pressure. I can't help
You're here. Lean for the. Two different things. Yeah. 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 Well, I imagine it's like you picture. Object. Our philosophy, we were also never negative.
That's how I love it.
Now you're ready. I took the combinatorial from the group.
So right hand side, we wanted to end ball from a bad
That should also be paid. Right?
Focus on the other part of it. And on the other part of it, don't worry about writing. Just discuss like what, dude, where are we running? Okay. Sounds good, sounds good.
Yeah, what it looks like.
Subcommittee of the committee. I like it. Okay, well, let's move on. This is great. Let's do the combinatorial.
Okay.
Yeah, this is all, I'll just cancel out.
Oh.
Very excited. Okay. Second. Yeah, like boys and then girls. Yeah. Choose one of them to be in front of. The gentleman who says, you know. So you choose these on, then you're distributing. Oh. Yeah, you have Yeah. That's exactly it. On the right hand side. Yeah, or idea of committee. Or you make this a committee. And then within that, we choose 10 dairy products. Yeah. Or that should be dairy product, right? Okay, I like that. So it's like, yeah. It's like, out of a group of people choosing a committee. Within that, choosing a subcommittee within, ice cream within dairy products. So it's all segregated. I think. When right. Out of all the Exactly. That sounds good. Why don't you guys go on?
The left looks good.
Sounds good. Okay, hey, let's go on to the combinatorial. That's all I have to say. This is just canceling. Let's focus on coming up with some counting.
You can write it wrong.
You know why? Okay, combinatorial preview. Okay. Just a quick comment here, so you're subcommittee first, and then you're forming the rest of the committee, not from the subcommittee.
No, no,
from
but we-
the meeting. Exactly. But I think you totally have the right. That looks good to me.
Yeah.
Nice.
We didn't signal, we already discussed it.
You discussed it. Okay, what did you discuss about that? I guess the hint.
Yeah, the hint does the left hand. That's right. Boy or girl.
So are you, do you have men boys and men girls? Same number of each? Ah, okay, great. Uh-huh. So that's saying choose K, yeah. So out of the hen boys, you choose K. And then you have 10 choices for the rest. Why? We have Barb, say
Okay, for the girl.
how many girls? And same one. This says form committees of size N. If I pick big boys and big girls, that's really out. I would want to see this explained this way first, and then point out that, oh, that's the same, yes. And then are we also choosing a? That's it. That's it. Now you add up all the possible values. Oh, I like it. Sounds good to me.
We have like.
Anybody?
Inside.
Right.
You feel like I'm for Bruce.
There are. The ones that are. K amount of power.
Yeah.
Okay, so it's like that. Like, we have to plan it. You pick extra K.
Are we giving up on the brother and sister thing? Don't just go on. That's just cancel the back to our own and fix it. Yeah, go on to number 2. I'm sure you could do that.
Next one.
Right.
I'm asking him a question because I legit just know where I got it.
And then we'll look at that.
Being mean unnecessarily. Not questioning. The question. Not questioning something like. That's different. Different.
Okay, let me replace that.
Yeah, I know. I thought you said.
Gonna work out?
I'm sure we're. By Robert. Like, Yeah.
Can't wait through the next week.
Forbidden by.
Do that thing, bro. Oh, okay.
Last week, I mean, this year, and the following. Yeah.
Okay, make sure he doesn't mess it up.
We just gotta make sure we can understand what he's doing. He's too good. You know, the first time he's doing. You have water.
Interesting. Our balls colors. And shape. It was good. Green.
It was good.
Five. From there, you're going to choose A of the green balls that have star shapes to it. Okay, I like this. I like that. Now you have to think about the other side. What that would represent.
Do a little more challenging between like peanut butter.
But, yeah.
All right. So we have to ask this.
Wait, I think it's series on the.
That's the binomial.
You know what R is? So-
Oh, you saw the yellow already.
Big.
No, no, yeah, so what's that, which is amazing. You can have it on the right. That's why you.
And so, but the formula doesn't say. Yeah, for recognizing.
The guy hated, bro. The guy hated. They hate us because they ain't no you.
But it was better than last one. Oh, yeah, start setting right. Next Thursday, man.
It's rough with that.
Exams like Thursday.
Basically, I know what's there. Talk with her. The February has. So now we take out. We're gonna be taking out by filming now.
It's minus one.
Yeah. So I need to take out, I need like positive.
Just surpass it.
You're fine. So first of all, I'm gonna get.
Ball.
Yeah. You're gonna go from here, but you can discuss.
With.
He can. Right. Now. The rest of the. Right inside. This is like choosing a boy. Mine's one thing. If you choose one boy, we can film by the, and boys, we can choose two, three boys, three. Oh, you're just looking at what the. Okay. Yeah, I'll get him. Yeah, I'm joking. Yeah, okay. Yeah, there is something about that. Where it feels wrong.
Yeah, yeah.
Because it's like it's fine, right? It's fine, it's the same.
Now we just like. And then M, that's.
Integrate one more time.
What I don't see here is limited integration. If you're putting it to depth, then you're really have to have a scene. I don't think you want, I think you want the limits on this intervention for definite. Oh, what I'm gonna do is let me this over here and let you take over the rest of those. You can fix it up more.
No, I think there is a limit. Then I did it like.
Is it? The integration of one to-
So that should be our.
Starts at zero.
Oh, well, you wouldn't wanna do that just because then you wanna be able to use that. You're gonna have like an equation. Stick the balls, I just any number of balls, whatever they are, you just choose them. That's basically the idea. Hey, God, I get another analogy that might feel a little bit more natural here. Would you say, suppose you're a bar. And you want to make a committee of size L. But then within that committee, you want to choose some of the committee members to be part of a subcommittee.
If you go from zero.
So you have these layers, you have the whole group, which is R, and you make a committee of size M. And then from that committee of size M people, there's gonna be maybe a K, I don't know.
Also,
So that would be this type of thing. You choose the committee, the committee chooses the officers. Here, you start with everybody, choose the officers first, and then fill out the rest of
Like we did the last one.
the size, to fill out the committee size. Now, you can choose resume additional. I kind of like that. So, yeah, this is fine. I think the committee analogy fits really better. Not totally. Why don't you try number two?
wanna try?
Yeah, you're.
Yeah. And then now, when you saw it on the right hand side, that's the fancy derivative, you see them plug in negative one unit. Yeah, no, but like, so you get. You would get.
Choose the president first,
You get one.
then fill out the rest of the page. Just choose it. Would be nice to be yours. Yeah, I like it, I like it.
Oh, okay.
You can't tell us what.
Yeah. Yeah, so I don't. If one house. That's actually like it's very bad. Or no, you don't get oh, we can do a virtual meeting. Double interview.
Yeah.
And I do.
Oh, it's kind of like private.
So we'll put some light on. On the homework, plus one to the end, that would just be.
Okay.
One plus X.
Why people don't. You're actually not. Whereas your limits are large, and zero, so go in this. It should be. You guys still have profession. Oh, no. Think we need to use different levels. Limits. We need to choose those. That's really. That's really. Sorry. Rain all over your brain. All I gotta do is fix this. That should be fine. They would change. There's put in white line. Once in one of the radios, I would change those. It's just we picked from your. Have you guys all done? So it's. Yes. So the weird part about problem three is this is one half, one square, one exploitation.
Yeah.
Yeah. Like, why is there a longer and are you taking this word that you're doing things like you're racing? Yeah. Like the binomial theorem, but that's what.
Power would be X to the N plus one.
Yeah. I would write down the binomial theorem. So with your. I also. And instead of that, why don't we put roots over in. So we can actually evaluate it from the upper to the lower limit based on what. You're on correct, but you want to choose, you write limits of integration to get the formula that you're trying to get here. So that way you don't have.
What are y'all working on?
You guys don't mind? I think you're gonna need two specific things. Yeah, two specific things.
Did you guys get that? We did. Okay, this should have a -1. Part of the formula. Oh, this is it here. Okay, not this part, that's just part. Right?
That's what we.
Which is. So I think you guys are. Are you guys? You were back there. So. Okay. Yeah.
Oh, right, you want us to get, right, so yes, they would. You don't want it, you know. You say. That's right. You plug in one.
Yeah. Hey guys, I know not everybody's quite totally done, but I do want to talk about something else. So if we could kind of wrap this up, even if you're not quite done, you got it right there at the end. That looks really good. No worries, as always, these are not graded and we're not worrying about all of that. But what I would recommend, of course, if you didn't have a chance to finish, if you could just check the solutions in Canvas. These group works, I think would be also good to kind of use to study for our exam coming up. The group works are not too overwhelming, right? Just a few problems at a time. So I kind of recommend that you follow up if you didn't have a chance to totally finish. But good job. I walked around and took a look at what everybody was doing, and it looked like a lot of good stuff there. So, okay. So with that behind us now, I think I would like to go ahead and talk about a new chapter. And we'll start it today and we'll talk more about it, of course, on Tuesday as well. But this is going to be coming out of chapter 6. This is the next chapter we're going to talk about. And the main topic here is going to be something called the inclusion-exclusion principle. The inclusion-exclusion principle. So this is going to tie in nicely to the stuff that we've been doing here pretty much for the whole semester up until now. The idea is that sometimes in an effort to count something, we might actually overcount the thing that we're trying to count and have to subtract out some kind of excess duplication that we might do. Like, let's say I ask you to take a couple of sets here, A and B, right? And I ask you, what is the size of the union of those two sets? Going back to some basic set theory, right? If I wanted to know the size of the union, well, I can think of that as the size of A. The first set is A, right? And then I could also add the set B, the size of B. But what I might notice here is that anything that was in both sets, in this sort of football shape here in the middle, right? Anything that's in both sets accidentally got counted twice. because it was in both A and B. But it shouldn't be counted twice because it's only one object, right? Each individual object in that intersection. So we have to subtract out that intersection. Okay, so this is a set theoretic way of thinking about this. And it's also extendable to 3 sets. So if I had, let's say A, and then I also had set B, and then I also had set C, right? And I wanted to know how many objects are there in the union of all 3 sets. Well, in this case, I could add up the size of set A. Okay, and then I could add up the size of the set B. I have this part here. And then I could add up the size of the set C as well. So I could add them all up individually. I could add up the size of A, the size of B, and the size of C individually, but now I've got to do some damage control because I've double counted some of the elements, and I've actually even triple counted the elements that are in all 3 sets. So the way you sort of start fixing this is, well, I'm going to subtract out the intersection of A and B again. So that sort of helps with the double counting in here. So I subtract out this intersection here, although I still have a double count of the triple intersection there. And then I would subtract, I can say, well, I also want to subtract out the intersection of A with C, sorry, A intersects C. Right, so I can, again, unshade in, you can't do this in your notes, obviously, but I can go ahead and just sort of show you here visually. So this is down to 1 time shaded in, and so is that. And so is that, right? And now I can subtract the intersection of B with C. Right, so that's going to uncount these objects 1 time. And is that going to be the right formula then?
No. No.
Not quite. Not quite, because if I do all of that, the stuff that's in the triple intersection, the 3-way intersection, right? It got counted once here, and once here, but then it got subtracted once here, subtracted once here, and subtracted once here for a net total of 0 times counted. So I actually have to now go back in and add up the 3-way intersection of A intersect B intersect C. And if I do that, it's a little convoluted, but if I do that, now everything in the union has been counted a net total of 1 time. Granted, in some cases, we counted it 2 or 3 times and then had to subtract it back out again. But at the end of the day, it has a net total of being counted exactly 1 time. Let's try an example here, guys, to practice this just a little bit. So here's an example. How many 7-letter strings have, sorry, not have. How many 7-letter strings start with a vowel, comma, end with the letter M, or contain the letter or the word kitten? And you know, I keep talking about how important it is to read these questions in combinatorics very carefully. This word here, or, is fundamentally important to how this is going to get answered. If it said and, it'd be a totally different answer. Okay, so this says or. Okay, so we can actually sort of formulate this problem in terms of sets that would line up with our general observation over here. And so I think I'm gonna try and do that just to make it somewhat more formal, as follows. So what I'm going to do here is I'm going to let capital A be equal to the set of 7-letter strings, starting with a vowel. Okay, so very good. A is the set of 7-letter strings starting with a vowel. And then I'll let B be the set of, I'm going to use a ditto symbol on the 7-letter strings part. The 7-letter strings ending with M. So the M is the last letter in the string. And then I'm going to make another set, which I'll call C, which is the set of, again, ditto symbol, 7-letter strings containing the phrase kitten. So we can make all of these sets. So whether you realize it or not, this is my clever way of asking 1, 2, 3, 4, 5, 6, 7 counting problems in one question. So I could like fill up a lot of space with just one question because of all these individual things we have to add up. Okay. Notice that there's no other restrictions. So we're not saying that repetition is forbidden or anything like that. This is kind of like license plates. Order matters and repetition is allowed. Okay, and it's a string of length 7. So we're going to still be using those fundamental counting ideas from earlier, but within the context of this, oh, sorry, I'm already doing this solution. Within the context of this inclusion exclusion. So what I'm really being asked for is the union, the size of the union of those 3 sets, because of the word or. The word or here is the key point. Okay, so I'm going to just write down the formula again here so that we can put the numbers directly below it. Size of A plus size of B plus size of C minus the 2A intersections of A with B, A with C, and B with C, and then finally adding back in the 3-way intersection of all 3 sets, like so. Okay, so let's do 7 counting problems really quickly. How many 7-letter strings would start with a vowel? Remember, the vowels are A, E, I, O, and U. Just those 5. Any thoughts on what the answer would be here? 5 times 26 to the 6th. Everybody good with that? Choose a vowel for the first slot. And then in the remaining 6 slots, we can choose any letter we want. We're allowed to repeat. And the order matters. So we just have 26 to the 6th for that. Okay, so I should put an equal sign here. And then we're going to go plus. And now let's do the size of the set B, just the set B. So how many 7-letter strings would end with an M? So the last slot, we have no choices, right? Has to be an M. But then the first 6 slots can be anything. 26 choices for each, 26 to the 6th. I think that looks good. All right, the next one is 7-letter strings that contain the word kitten. So I have to think about that now. Kitten is a 6-letter block, right? That we already are forced to have. 2 times 26. Do you want to explain that?
Well, kitten is the block. Those 6 letters.
Okay.
You just have to choose whatever letter you're.
Right. So we could have the kitten here at the beginning
Yeah.
and then one more letter there, right? Or we could have the other letter at the beginning and then the word kitten, right? That look right? So that's why I've got a factor of 2 there. And then for each of those 2 cases, we have 26 choices for what that extra letter could be. So 2 times 26, I like it. Okay, so that's strings that contain kitten. Okay, from there, now I'm going to start subtracting the two-way intersections. So A intersected with B, these are 7-letter strings that start with a vowel and end with an M. So if we need to, we can start drawing slots to kind of help us figure these things out. Here's 7 slots. I'm going to put an M in that last slot already. There's no choices about that one. And then we have a vowel going into the first slot. So we've already talked about this before, that's 5 choices for which vowel goes in the first slot. And then what happens in the middle slots? 26 choices for each of them, right? We have no constraints at all. So 26 to the 5th, right? So multiplying all of that together, it would be 5 times 26 to the 5th power. And now let's do the intersection of A with C. So now I want to have strings that contain kitten, but which start with a vowel. How many of those would there be? Just 5 of them, right? You either have A kitten, E kitten, I kitten, O kitten, or U kitten, right? Literally 5 of them. Excellent. Okay, so we got that. And then B intersects C. So now I want to know how many strings end with an M that also contain the word kitten. There's only one way to do it, right? It's kitten M. That's it. That's the only thing you can do. All right, fantastic. And now finally, the 3-way intersections. This is how many strings start with a vowel, end with an M, and contain the word kitten.
Not possible.
It's not even possible, is it? Right? Because you have to basically have the whole phrase kitten. You have to have an M at the end of it. But now you have no room to put a vowel at the beginning. You filled up the whole thing. So this is actually zero. Okay. And when you're doing these inclusion exclusion problems, I love seeing the answers just spelled out like that, right? Again, punching it into a calculator and giving me a numerical value is less insightful to me as in terms of understanding your answer than having all those terms kind of spelled out there. Right. Okay. Everybody feel okay so far?
So for the last part?
Yeah.
Since there's 0 of them, right?
Uh-huh.
What it means empty, right?
It just means the intersection is empty. Yeah.
Right, but we're talking about the cardinality here, right?
So it would be 0.
Okay.
Yeah, the empty set has nothing in it. Yeah. Good point. Okay, let's try one more. Let's try one more that's just a little bit different nature. This one was kind of like a inclusion exclusion of problems that look like license plates. Let's do a different one that is involving poker hands, poker cards. So let's do this. How many 5-card poker hands? How many 5-card poker hands contain exactly 2 spades, at most 1 heart, or a flush? Do you guys know what a flush means?
It's all the same suit.
Right, all 5 cards are the same suit. Okay, so be careful how many of these terminologies you confess to knowing. I might be wondering what you're doing on your weekends. Okay, this isn't that far. I think you can get there. Yeah. It's not too far. Anyway, so again, guys, just like the first example, the word or is critical here. The word or is really critical. So I'm gonna set up my sets again, just like I did on the last one. We'll do the solution over here, I think. So this time I'm going to let capital A be equal to the set of 5-card hands with exactly 2 spades. Okay, so there's a good set capital A, and then I'll make another set, which I'll call B, which is the set of 5-card hands with at most one heart. Right? And then finally, I'll make a third set, I'll call it C, which is gonna be the 5-card hands with a flush. I should probably, just in case there are some folks who aren't clear what a flush is. A flush, as we just said, a flush means all cards in the same suit. So all of them are hearts, all of them are clubs, all of them are diamonds, or all of them are spades. Okay. And just like before, guys, we are gonna find the size of this union. So again, I'm gonna write out the inclusion-exclusion formula for 3 sets, which again has 7 individual counting problems associated with it. It's just the same thing again, just practicing it one more time with a different example, this time with poker cards. And we're gonna go through and try to figure this out. This is good practice on the old material too, by the way. Each one of these is a good review of some earlier material. This time we don't care about the order because we're talking about poker hands. So we're not gonna see things like powers of any numbers here. We're just going to see combinations because we're just going to be choosing the cards. Does anybody want to give me an idea how many 5-card poker hands would have exactly 2 spades?
4 times 13. I think it's about like 13 cards per 1 suit, so there's 4 cards. Like options. Oh, and then like the street factorial, not just power.
Factorials make me feel like we're putting things in order. You know, I don't think we should actually.
5. Oh, yeah. Yes.
So let's get this constraint figured out first. We have to have exactly 2 spades. How many spades are in the deck? 13, and I'm going to do what with those? Choose 2. Very good. 13, choose 2. Let's just do that much. And how many cards do we still need to fill out?
There'd be 2 cards that you have that are spades, so then you just gonna choose them.
Exactly. So we have 39 other cards, right? Because there's clubs, diamonds, and hearts. And we choose 3 of those. Beautiful. I love it. I love it. I love it. So that's the set A. Okay? Everybody comfortable with that? You choose the spades, then you choose the non-spades. Awesome. Okay, let's look at set B here. These are 5-card hands that have at most 1 heart. So, thoughts about that? I could have no hearts or I could have 1 heart. At most 1 means either 0 or 1. And I would rather solve both of those 2 problems than trying to kind of in one breath get the answer here. So let's imagine that we want to have no hearts. 0 hearts. Then how many ways would there be to make it? 39 other cards. I choose all 5 of them from those 39 cards. Those would be the spades, clubs, and diamonds, right? And to that, I need to add, notice I'm using the addition principle because I'm now doing another case. I need to add the hands where we would have exactly 1 heart. And that works very much like the original set A with exactly 2 spades, except this time I'm only choosing 1 from the hearts. And then from the other 39, I'm choosing 4. Okay, so it should be something like that, right? Something like that. That's the size of set B. I gotta find out how to write a midterm that only has 1 problem on it. And I can just do it with like 4 or 5 sets and that's I know. I had I always hated it when my professors would only give me one question to solve. I was like, what if I don't get it right? For next year?
Yeah.
I'll save that idea for the first year. I got, maybe for the year right before I retire. I'll give the exam and then I'm gonna go run and hide. Anyway. I gotta finish this up. Let's finish this up, guys. Give me a couple extra minutes. Let's do this quickly. Flushes. How many? Or choose one. I have to choose a suit. And then from that suit, I'm gonna take all 5 cards to be from that suit. So I like it. 4 choose 1 times 13 choose 5. Everybody good with that? Choose a suit and then choose 5 cards. Awesome. Okay, now we start subtracting. I wanna do, oh boy. Exactly 2 spades, but at most 1 heart. So that's actually back to the 2 cases again. It could be 2 spades, 0 hearts, or 2 spades and 1 heart, plus whatever the other cards are. Let's get some parentheses here for this, because we're gonna have some cases. 2 spades, that's 13, choose 2. If I do no hearts, then I'm, so the no hearts case would be, I'm not gonna use any hearts, I'm not gonna use any more spades, I only have 26. 26, choose 3 more cards, and those 26 could be the clubs and the diamonds. Or, I need a little more room, I could do my 13, choose 2 for my spades,
And then
I can grab 1 heart, 13, choose 1.
And then 36.
26, choose 2 more cards. I like it. Okay, so that would be A intersect B. Okay, how many flushes have exactly 2 spades? Impossible, right? Because a flush has 5 cards in the same suit, right? All right, I think we're getting there. What's the next one?
Also 0.
B and C. At most 1 heart, but it has to be a flush.
0.
No.
Well, because you can have the case where you have no hearts and it still be a flush.
I could have no hearts and have all of them diamonds, all of them spades, or all of them clubs. So there'd be 3 suits that I could make my flush with. I can't make my flush using the hearts anymore. So 3 choose 1. And then from those 3 other suits, not the hearts,
Yeah.
I can now make a flush. Okay, so that is possible. And then finally, guys, if I have seen a 0 anywhere up to this point, right? Then when I do the 3-way intersection, it's got to be 0, right? Because you've already, even just intersecting A and C, we got 0.
I don't believe I've seen.
Well, how much time do you have, Fernando? So I think that would be the answer. So these are 2 examples of inclusion, exclusion. On Tuesday next week, I'm gonna give you the full big general inclusion exclusion principle for any number of sets, not just 3. So there's a nice big formula we can do for that. I'll do it with you next week. Thank you so much, guys. Have a great rest of your Thursday. Again, come on down soon if you want to talk to me today.
All right.
Thank you, Professor.
Have a great day.
I won't be looking.
I don't use the great coffee. I might go somewhere like this, I feel like I need to sit there and refill responses on my, I'm more of a.
Doing something like that.
Fast food. Just gonna hang out.
I don't like to go to places and like sit down at a waiter if it's there. Sitting there for. So I usually go somewhere where I can't help myself. Have a good day. You too. Bye bye. Oh.
Can I have a question about the group work?
Yeah, please.
When I integrated it, I got this answer, so I'm so close, but I still think there's some value in it.
That's what you should have. So the only thing is that what you needed to do is have limits of integration on your integral. So I see this plus C here. That makes it look like you did an indefinite integral without limits. And the way you do this, if you put limits on it, then you'll be subbing in for the X value.
Gotcha.
That's gonna be the trick.
Yeah, I actually do that. I haven't been calculus.
It's gonna matter.
Oh, no. There won't be too much calculus here, but there's a few places where it comes up. Great day, guys.
You're making a fortune, right? You're making a fortune, and